Hello everyone, with another example related to forces acting on objects. I have two objects here, or two masses, m1 and 2, and the question describing them as 9.8 kg is the hanging object, which means it's m2. It's connected by a light uh, inextensible cord over a light frictionless pulley to a 5 kg block that is sliding on a table. Okay, so he's saying here there is a sliding on the table, taking the coefficients of kinetic friction as 0.185. Find the tension and the rod. Sorry, I forgot to mention the rod here, or the cord, whatever you want to call it, it's fine. So let's distribute the forces here. The usual I will have here is m1g. I will have the Fn. I definitely have a tension pulling rope, and as he said in the question, is sliding, that means there is a motion. Then the question confirming there is a motion by saying friction of kinetic. So this one will be Fk. Sorry, let's fix this one here. Yeah, it's the kinetic friction force. Here I'll have another tension, or it's the same tension, m2g. Okay, there is no other forces to add. Now once again, let's do it as we did before in previous example or previous video, to apply Newton's law, the second Newton's law, on each object, and we'll see. Now for object 1, total forces on the x-axis, it will be T minus the friction force equal m1a. Now for the second object, using Newton's law, we'll have m2g minus the tension equal m2a. Now we're gonna eliminate the tension to find this new equation, m2g minus the kinetic friction equal m1 plus m2. That will equal acceleration. Someone might ask, like to tell, okay, why we didn't use the top equation from the mass one, just straightforward and find the tension? Well, we can't do that because simply we don't know how much is the acceleration of that object. If we go to the second equation, we will be facing the same challenge. We don't know the acceleration yet. So we have to find the acceleration and replace it in one of these equations to find the tension. Okay, so that's the reason why I went directly to find the acceleration, then I will find the tension. Now from here, the acceleration will be m2g minus the friction force, or the kinetic friction force, over m1 plus m2. Okay, sorry about this one, let's fix it quickly. It's m1 plus m2, and here we go. Now we're gonna find a small hiccup here, that we need to figure out how much is the kinetic friction first. So we can do that here on the side very quickly. The kinetic friction will be the mu k multiplied by the normal force. Now the normal force, we know it is from the y-axis on object 1, and we can do it by using what we learned from our previous videos, that here is the mu k, and the normal friction will be equaling m1g. That will be the normal force. So I can use that and place it straight forward to just save my time. Now the acceleration will be like this then. will be M2G minus mu the kinetic coefficients M1 times G. Then I'll divide that all on M1 plus M2. Now just we do the math and placing the value of each one of them. Divided on, that will give me the acceleration is 5.88 meter per second square. That will be how much is the acceleration of the system. Now, having the value of or the magnitude of the acceleration, I can pick this equation or this equation to help me finding how much is the tension in this cord. So I can do it here, and I'll change the color just to make sure. So I will pick this equation. Okay, so it's M2G minus T equal M2A. Just by rearranging the formula, T will equal M2 will be the common factor here, and it will be G minus A, and from here we're just placing the value. M2, remember, is the hanging one, that will be 38.4, and the unit is in Newton for the tension. That will be the tension on this rope, cord, cable, whatever the name is for it. That will be the tension between these two masses on this system. I hope you found this example useful, and I'll see you again. Thanks.